To solve this, we need to look up some appropriate values. There's a link to useful values in your slideshow. The radius of the moon will need to be known, and looking that up, that is 1.74 times 10 to the 6 meters. And the mass of the moon will be needed, and the document lists the mass of the moon to be 7.35 times 10 to the 22 kilograms. Okay, so with those values, we can answer this question. We're asked for the gravitational field strength at the surface of the moon. So we are going to use the formula G equals universal gravitational constant times the mass of the object creating the field, which is the moon in this case, divided by the square of the distance, which is going to be the radius of the moon. So I'll just fill in the values and put it in the calculator. Now I know that the answer should turn out to be approximately 1/6 of the value for Earth, so we'll see if we get that. Okay, putting it in the calculator now. Okay, so I'm coming out with an answer of 1.62. It has 3 significant digits based on all the given values there. This would be in newtons per kilogram. And yeah, that is pretty close to 1/6 of 9.8. So I think that's the right answer. So that's part A. Now part B. Commander Hadfield is in a spaceship where the moon's gravitational field is 10% weaker than on its surface. How high above the lunar surface is the commander? Okay, so I'll use different color here. So Commander Hadfield is somewhere up there in a spaceship. And how high is it? Okay, H is what I'm looking for. And it's known that the gravitational field strength is 10% weaker. So basically it's 90% of 1.62. Okay, 10% weaker means it's only 90% of the original. So that would be 0.90 times the answer to part A. So that's 1.457. I'm going to keep an extra digit just in my steps here. So I have to find out what height creates that. So I'm going to use the same formula, but solve for the r variable this time. So rearranging for r, it's going to be the square root of capital G times the mass divided by gravitational field strength. It'll be plus or minus, but the negative is inadmissible, since we're not going to have a negative distance. Okay, I'll fill in the values. Okay, now I'll put it in the calculator. Okay, so I'm getting 1.83 times 10 to the 6 meters. Now keep in mind that is the value of r. So that is the value from the center of the moon all the way to where Chris Hadfield is. But I'm interested in finding just the height from the surface, this h value there. So I'm going to have to do a subtraction, actually. H is going to equal my answer above, subtracted by the radius of the moon, leaving me with 0.09 times 10 to the 6, which is not actually proper scientific notation. So I can write that as 9 times 10 to the 4 meters. That would be how high above the surface Commander Hadfield is from the moon.